Hello and welcome to this presentation of the 2015-2016 Central Indiana Winter Outlook, presented by the National Weather Service in Indianapolis. My name is Mike Ryan. I'm one of the meteorologists here, and over the next half hour I'm going to talk with you a little bit about some of the different factors that are likely to influence the remaining part of the winter. Here in mid-December, and it's already been very warm through the first half of December and really throughout the fall as well. And we haven't had much in the way of snow or winter of any kind. Doesn't mean that's the way the entire winter is going to go. And I'm going to show you some of the things that we're looking at to try and make some forecasts for what we think will happen as the winter goes on. As I list here, it's not just about El Nino. That's what we hear about in the news and what we've heard about for the last several months. And rightfully so, because the El Nino is one of the strongest on record currently. And I'll explain how we measure that and what that means. But El Nino is not the only factor regulating weather, not only here across the Ohio Valley, but across the United States. There are other factors as well, and we'll get into those different factors and the influence they may have over the next half hour or so. Before we get into that, though, I want to take one quick look back at last year's winter. And when we talk about the winter, we classify meteorological winter as December through February, those 3 months. Now, wintry weather and snowfall can occur before that in November. It can occur in March and even into April. But we focus in on those 3 months from December to February, which accounts, again, for the meteorological winter. And last year, we had a mild December. Again, these numbers are for Indianapolis. And we were about 2 degrees above average in December, but then as the winter went on, it got colder. In January, we ended up almost 3 degrees below normal, and in February, really the bottom fell out. And you can see not only were we almost 12 degrees below normal on average in Indianapolis, but we also saw the bulk of our snowfall last year as well. We saw a little under 26 inches of snow for the entire season, not just the 3 months, including December and February, which put us very close to average in Indianapolis. We averaged just under 26 inches of snow for the entire season, and you can see we had a little over half of that in February alone. And on top of that, if you look down here and you see in March we had 5.9 inches, the bulk of that fell in the first 8 to 12 hours of March, and that was due to a snowstorm that impacted the area late on February 28th and into March 1st. Now, the average snowfall we see in December through February is 22 inches, and then, in the months surrounding that, we pick up a few additional inches to get us to around 26. But again, overall, we had a colder than normal winter, drier than normal winter, as you can see here, to the tune of almost 2.5 inches. And then we had less snow than normal during these 3 months. But again, with snowfall we received in November 2014 and March 2015, that put us very close to normal for the entire winter snow season. So, as we look ahead to this year, I want to start with the winter outlook from CPC, or the Climate Prediction Center, and they make these outlooks for the entire country. And a lot of people misinterpret what they're seeing on this map. They see these brighter colors, these warmer colors across the northern part of the country, and they see these cooler colors across the southern part of the country, and immediately think that must mean below normal temperatures down here, above normal, and maybe way above normal temperatures here. And that's not exactly what they're forecasting. What CPC is saying in this graphic is it's showing that based on everything that they look at, looking at climatology, looking at past winters with similar conditions, taking into effect all of the factors that are in play for this winter, which we'll talk about, not just El Nino but other factors, they come up with a probability, and that's what these numbers show. And so, for instance, here you see this 33, that's a 33%, and likewise a 33% here. So when we're at 33%, you can imagine 33 plus 33 plus 33 takes you to 99, or right around 100% essentially. It's saying that there's no strong signal towards greater than normal or cooler than normal conditions, and that's kind of what you're seeing where this says EC, equal chance of everything. For Indiana here, what it's saying is, as you can see, we're kind of in between this 33 to 40%. What that means is that based on all of the data they've taken into account, there exists a slightly greater chance of above normal temperatures across this area, to the tune of 33 to 40%. Now, in the grand scheme of things, that's not huge. But what it's saying is, it's not saying that we're going to be above normal. It's just saying that the chances to be above normal through the 3-month period is greater. And certainly, at least here through the first 15 days of the month of December, it seems to be playing out that way with just how warm we've been across the area. Precipitation-wise, this kind of works the same way. This is, again, the forecast they put out when they put out their main winter outlook in mid-October. And typically during an El Nino season, the storm track is very active across the southern part of the country. And so areas along the Mexican border, along the Gulf Coast, and in Florida tend to be wetter than normal. And you can see the signal's very strong for that, especially in the southeast, where we're talking about 60% and greater chances to be wetter than normal. Now, probably the strongest signal that we tend to see when we're dealing with any sort of an El Nino event across the Ohio Valley, and especially a stronger one, is we tend to see drier than normal conditions. And part of the reason for that is because the jet is more active and the storm track is more active to our south. And so we tend to be a little drier further north. Doesn't mean the storm track doesn't occasionally come up into the area, but it does so with less frequency. And you can see, the chances are about 40% chance for below normal precipitation. And again, so far through December, we've started out on that trend with drier than normal weather so far. I think we're about an inch to maybe an inch and a half down here in Indianapolis since December 1st. And so we'll see how that plays out. But as I'll show you, drier than normal does not necessarily mean less snow than normal. And I'll show a couple of examples of that as we go out in time. So many of you may want to know what is El Nino, and specifically what is the El Nino Southern Oscillation. The El Nino Southern Oscillation talks about and focuses on anomalies or differences in sea surface temperatures from their normal state in the equatorial Pacific Ocean, so near the equator. And when the phase shows much warmer than normal sea surface temperatures in this area, we classify as being in the El Nino phase, and that's where we are right now. When they're cooler than normal, we classify as being in the La Nina phase. And what happens when we have this going on is these differences in sea surface temperature can create differences and influences in storm track and weather downstream across the Americas and especially across North America. It's not the only factor, but it is a big factor in determining how our winter plays, and where it seems to be most active, where El Nino can have the greatest influences, is typically during the winter season. Now, this is just a very basic schematic, and it highlights all El Ninos, doesn't really take into account strength of El Nino. But what it shows is that typically the storm track is pretty active and consistent across the southern part of the country, and your polar jet stream a lot of times will stay to the north. And the result is that you tend to get warmer than normal conditions not only across Alaska and western Canada, but into the northern part of the country, and wetter and cooler conditions near the active jet, the active storm track across the southern part of the country. And we're kind of right in the middle. And you can see dry, but we're not that far from the cooler than normal. We can see warmer than normal, but it creates a lot of variable weather, and that's really the bottom line. El Nino can make things more variable and cause many changes in the flow that we see in the atmosphere over the United States. And for us here in the Ohio Valley, it can create a lot of differences in month-to-month variations in temperature, rainfall, and storminess. And the strength of the El Nino is critical. But as I'll show you, even with this year's being one of the strongest that we've seen in recent memory and in record going back into the 1950s, doesn't necessarily mean that some of the things that we've seen in past years where we've had very strong El Niños are going to be the same things we see this year. And that's kind of my point with this slide. No two ENSOs are the same. No two El Niños are the same. And that's why making a blanket statement like, we're going to have El Niño this year, so it's going to be warm and dry. Well, that's not very accurate. We talk about the warmer water near the equator. Well, if it's here in this part of the Pacific versus this part, that could be lead to some differences in how exactly the impacts play out downstream across North America. And every El Niño is a little different, and that needs to be taken into account. And that's where we take a look also at what some of the other factors are that are influencing our weather. And one thing I'll show you is some of the things that we have this winter we haven't seen in previous winters with strong El Niños. So exactly how that's going to impact things is a big question mark. Now, let me scroll back here for a minute. Probably the area that's used most by NOAA and the National Weather Service is the Niño 3.4 region. And this takes kind of the biggest snapshot through here of what the water temperatures are doing in that zone in the Pacific near the equator. Now, this was a weekly reading that was taken just a few days ago on December 14th, and they're updated every week. And you can see that we're running at nearly 3 degrees Celsius above average on water temperatures in the equatorial Pacific. And so that's in excess of 5 degrees Fahrenheit. That's very significant, and that just alone classifies it as one of the strongest El Niños that we've seen on record. You can see going back to earlier here in 2015, it's been a steady climb. March, we've been warming steadily up to here into the fall, but as you can see, we peaked here in late November, and we've actually dipped back a little bit over the last 2 weeks. And what's going to be interesting going out through the rest of December and into early January is whether or not this is going to be a trend, or whether we're going to see the temperature steady or come back up, or whether we're going to start to cool over that area. And the forecast right now is for us to be very close to the El Niño peak, with the water temperature beginning to cool as we move into the early part of 2016. And that could have a big influence on how the latter half of the winter develops, not only across the Ohio Valley, but across other parts of the country. One thing I want to show you, and you've probably heard if you've been paying attention to various weather sources over the last few months, is there's been a lot of talk about this warm blob. And what that is it's been a warmer pool of water that's been sitting off of the American West Coast really since the summer. This is a larger picture here to the right, and you can see that very clearly off of the North American coast right here. This is the main warmer than normal water temperatures right along the equator right here. And then when we zoom in closer, you can see how that looks. Now this is from back in November, and I didn't update the maps to take into account the last 4 weeks or so. We've seen a little bit of cooling as we've moved into December in this area where the warmer blob of water has been off the west coast, but it's still there. And so the questions have become, what impact is that going to have on the upper level flow at 15, 20, 25,000 feet off the ground over the lower 48? How will it influence our storm track? Because in previous strong El Niño winters, we haven't seen this blob of warm water. So we're not quite sure the impact it's going to have. Some thought is it may force storms up and over where the warm blob is because of that warmer water, force it up and over, and that would tend to produce what we call a trough of low pressure in the upper levels of the atmosphere across the eastern part of the country or downstream from this area. And that would tend to enable cooler than normal conditions and maybe more unsettled conditions to develop across many areas east of the Rockies. We really haven't seen that occur yet, but that's just another factor that we need to consider. Just really quickly, one thing that the Climate Prediction Center looks at is they have a bunch of different models, and you have models highlighted by all these different lines indicating a forecast or a plume of what they think El Nino is going to do, and more specifically what they think the water temperatures are going to do in the equatorial Pacific over the next year. You can see this goes out. These are in 3-month periods going out all the way into the late summer, early fall of 2016. And this is where we're sitting right now. The black line is what's been observed. And you can see we're sitting between 2.5 and 3 degrees Celsius. But the forecast is for this to start falling, and in some cases falling fairly rapidly as we head towards the summer. And there's a hint that we may even completely move out of El Nino conditions by the summer, and maybe even move into the other phase, La Nina. So again, that's consistent with what we've talked about with weakening El Nino conditions as we go through the latter half of the winter. And the impact that may have is something that's going to be very interesting. So I want to shift gears and talk about things that have happened in the past. Climatology is always an important aspect when you're looking and trying to make forecasts over a seasonal period. And this is not a forecast of what will happen this winter. I'm going to give you an idea of what we think we may see, but we're not going to make a generalized forecast. We want to put together some various things and give you a feel for what we might expect. So let's start with winter season normals in Indianapolis, again during the winter season, December to February. And you can see that our average temperatures start out between 31 and 32 degrees in December before dipping down to around 28, back to 32 in February. So we end up around 30.5 degrees. We average a little over 8 inches of precipitation. And we average, again, about 22 inches of snowfall. And that usually in a typical winter is fairly evenly displaced between the 3 months. Now, as I mentioned, of course, it's been very warm so far in December, and in fact, our average temperatures are running up over 40 degrees right now. So we're running well above normal for December. Now, in strong El Nino years, and there are 6 that we looked at going back in time since 1950, and that's the winters of 1957-58, 1972-73, 1982-1983, 91 and 92, and finally 1997 and 1998. And that's where we had sea surface temperature anomalies that were at least 1.5 degrees Celsius warmer than average, and that was what would classify a strong El Nino. And I've highlighted the 82, 83, and the 97, 98 years because those were the strongest El Nino events on record, and at least from looking at the sea surface temperatures, the strength this year is rivaling those years. As you can see, when we've had that in the past, we've been much warmer than normal, to the tune of about 3 degrees above normal for the entire season. December in particular tends to be quite warm, with the averages kind of decreasing and getting closer to normal as we get into February. Precipitation is below normal. Tends to be wetter in December. We haven't seen that to this point, but on average we run about 2 inches below normal in these years, and snowfall is way down. And you can see that here. In these 6 winter seasons, we've only averaged about 6 inches of snow during these 3 months. When we take into account the months surrounding these 3 months, November, March, April, it still only averages out to about 10 inches of snow. Now when we go to moderate El Nino years, and that's classified as seasons that are to the tune of about 1 to 1.5 degrees Celsius above normal on average on the sea surface temperatures. You can see things vary a little bit, and these are the years we're looking at. Again, six years. 1965, 1966 is highlighted because that is very close to the strong category. The sea surface temperature anomalies were right around 1.5, so in some studies you see that included in strong, and some you see it included in moderate, and for the purpose of our analysis here I included it with the moderate. But you can see typically a warmer December in these moderate El Nino years, and then we tend to flip in January and February, and depending on the strength of how great the flip is and how warm December is ultimately determines where our seasonal average ends up. And at least in these 6 winters, we've averaged about 1 degree below normal on temperatures. We still remain drier than normal, but look at the flip on the snowfall from what we showed with strong El Nino years. After a month, typically in December, where we just don't see a lot of things happening, we tend to do very well with snowfall in January and February in these years. And actually, we end up averaging a little bit above normal. And one thing that's interesting is these two last winters I have listed below, 2002, 2003, and 2009, 2010, were moderate El Nino years, as we have listed. Both saw seasons and snow years that were above normal across not only Indianapolis but the central Indiana area. In 2002, 2003, Indianapolis received 50 inches of snow for the entire season, including November, March, April. And in 09-10, we saw about 34 inches of snow. So there were other factors that were in play those winters, even though we had a fairly decent El Nino going on that enabled us to see more snow than not. And I think it really just kind of hammers away at the point that just because we have an El Nino going on doesn't necessarily mean we're talking about warm conditions throughout the winter across our area. You've got to look deeper at the details. This is a map that the National Climatic Data Center, now known as NCEI, put together looking at those years that we talked about with stronger El Nino events, and you can see they included 65, 66 in the stronger set here. But these are climate divisions in the different states broken up, and the thing that stands out right away is how temperatures in these winter seasons with the strong El Ninos tend to be well above normal across the northern plains, down through Iowa, and even here into Illinois and Indiana. We're talking about average temperatures on the order of 1 to 3 degrees above normal from south to north. And the cooler signal with the wetter and cooler conditions we've talked about across the southern part of the country show up very nicely. One thing I stress when we talk about science and meteorology is you have to be careful when you look at composites, because this is taking data from 6 separate years, and it can sometimes mask the variation between those 6 years. So let me show you those 6 years separated out. And you can see, if we go to 82, 83, 91, 92, and 97, 98, that strong warm signal across the northern plains and into the Great Lakes does show up. But look at 65 and 66, and 72 and 73, and even 57 and 58. It looks much different than the map we have here. And so there were other factors that were in play those years, that likely contributed to temperatures being closer to normal, or in some cases even being below normal. And that's why we have to be kind of careful. It's very hard to make that blanket statement. Now, I did want to show the same sort of a composite with the precipitation anomalies, and this is why I talk about the stronger signal for drier than normal conditions across the Ohio Valley. They show up in almost every winter season that we look at here, those 6 winters. And it's the strongest signal noted, at least towards drier than normal conditions across really the entire country. But as I said again, just because we're talking about drier than normal conditions, potential greater possibility for that does not always mean less snow than normal. And a perfect example I'm going to give you is this, and this is courtesy of Jeremy Capel and WDRB TV in Louisville. I appreciate him being willing to share this stuff with us. The 97-98 El Nino, as I mentioned, is easily one of the strongest, and certainly the one in recent memory that everybody remembers. In Indianapolis, we only received about 10 to 12 inches of snow for the entire year. But what a lot of people forgot about is this, what we call the forgotten snowstorm. And this was an event that developed over a 2 to 3 day period in early February of that year, in 98. A strong low pressure developed off the Carolina coast, and it brought not only Gulf moisture, but very strong Atlantic moisture back into the Ohio Valley. And the air was cold enough to produce a prolonged period of heavy wet snow across the Ohio Valley. In fact, to the tune of a wide swath of 6 to 12 inches that extended from the western Maryland mountains back across southern Ohio and even into southern Indiana and northern Kentucky. And there was a stretch between Louisville, Lexington, and Cincinnati that saw between 1 and 2 feet of snow. As crazy as that was, the cutoff was very sharp going north. Louisville for the event had over 22 inches of snow. It's one of their heaviest snow events on record, or it may be their heaviest snow event on record. Cincinnati had over 1.5 feet. Here at Indianapolis at the airport, we measured a mere 0.6 of an inch. Now, there were areas across southern portions of central Indiana, when you got down towards Bedford and Columbus and Seymour, that saw several inches of snow, but not a lot of snow here in Indianapolis. And imagine if we could go back and this storm event was 100 miles, 50, 100 miles to the northwest. Then instead of Louisville and Cincinnati seeing a foot of snow, we would have seen that here in Indianapolis. And it would have completely changed the amount of snowfall we would have had that year. We would have ended up with near normal snowfall. And I show this because it kind of highlights the variation that we can see. Just because we're dealing with a strong El Nino doesn't mean we're not going to see snow. We can still get snowstorms, and pretty good snowstorms at that. And this is a perfect example of that. I want to show a couple of graphs as we near the end. These are probabilities for Indianapolis in December, January, and February when El Nino is ongoing. And I show this to just kind of highlight that the variation is not great. Now, this is taking all El Ninos into account, not just strong. But you can see, on average, we're only slightly greater likelihood during an El Nino event to be warmer than normal here in Indianapolis, to the tune of 36% to, say, 32% of being near here in the gray, or 32% in the blue. The signal's a little stronger when it comes to precipitation, which I think was highlighted pretty well in the maps I showed you, of nearly a 45 to 50% chance that we're drier than normal during an El Nino event, whereas only about a 20 to 25% chance that we're wetter than normal. When we broaden that out to the Climate Prediction Center region number 24, which is a geographical region that covers a good chunk of the southern half of Indiana, including Indianapolis and most of central Indiana, over into Illinois, you can see there's a little bit greater warm signal during an El Nino, about 40% likelihood of warmer than normal conditions during an El Nino versus only 32% at cooler than normal. Again, that's not a huge difference, but it's there. And again, the drier than normal signal is quite a bit stronger. 50% likelihood of drier than normal conditions in an El Nino in this area versus only about 14% wetter than normal. Before we get into kind of our finishing thoughts, you've maybe heard about teleconnections, and I'd like to briefly talk about that because these patterns can definitely have an influence on how the weather changes during the winter or during different parts of the winter. It's a naturally occurring aspect of our chaotic atmospheric system, the upper levels of the atmosphere, and reflects large-scale changes in the upper level wave and jet stream patterns, which ultimately influences temperature, precipitation, and storm track. There can be some influence from the El Nino Southern Oscillation cycle, and these I list below. The NAO is the North Atlantic Oscillation, the AO is the Arctic Oscillation, PNA is the Pacific North American Oscillation, the PDO is the Pacific Decadal Oscillation, and the EPO is the East Pacific Oscillation. I'm not going to go into specific detail on all 5 of them, and really we don't need to throw in that detail. I can just talk a little bit about how they influence our weather and impact when certain things are ongoing. Let's first talk about the NAO and the AO, the North Atlantic and the Arctic Oscillation. When these go into a negative phase, and they're measured by differences in the atmospheric patterns aloft, when we go into extended periods of negative phase for either, that trends towards colder and more unsettled weather for central Indiana and the Ohio Valley during the winter. When both indices go negative at the same time for an extended period, that gives us a much higher confidence in a colder, and in a lot of cases a much colder and snowier pattern. Perfect example of this was in March 2013, and some of you may remember that. It seemed like it was never going to warm up. And March was a very snowy month. We saw temperatures on average that were nearly 10 degrees below normal across the area. And in fact, you may remember the last week of the month that year, I think it was the 25th, 26th of March, we had 9 inches of snow in Indianapolis, which is really unusual for that late in the year, or late in the season. And the North Atlantic Oscillation and the Arctic Oscillation, not surprisingly, were both negative at that time, and so that trended towards a deep trough developing across the eastern part of the country, and again, a higher confidence in a much colder and snowier pattern. Now, these are charts that, again, are back from in November. One challenge with all of these teleconnection patterns, especially the Arctic and oscillation and the North Atlantic oscillation, is that it's very difficult to forecast them out more than a couple of weeks ahead of time. And that's what this graphic shows. As you can see, through the fall, we've been positive. We dipped down into briefly negative in late November, and we've been back in the positive phase again as we've been into December. And so, not surprisingly, we haven't really seen any cold weather. And there are some hints, and I don't have the maps here, but there are some hints that we're going to trend towards a more negative pattern as we get towards the end of December and into early January. So it'll be interesting to see if we start to trend as we get into the new year towards a colder pattern. Now, the EPO and the PDO kind of work together, and again, I'm not going to go into big detail on this. I'm just going to kind of give everyone a feel for how they influence our weather. With the Pacific Decadal Oscillation, it's just a recurring pattern of climate variability caused by interactions of the ocean, the water temperatures in the atmosphere over the mid-latitude Pacific Basin, so the northern Pacific Ocean. When the Pacific Decadal Oscillation is positive, it tends to influence a ridge out over the North Pacific in Alaska and along the west coast, which then proceeds to promote a trough downstream across much of the eastern half of the country. And the PDO, for the most part, has been positive over the last two winters, and that has influenced how our winters have played out in the 2013-2014 and 2014-2015 winters. And not surprisingly, it continues to be mainly in a positive phase as we go into this winter. So the question is, how is that going to influence us going forward over the next few months? The Eastern Pacific Oscillation is really the Pacific version of the North Atlantic Oscillation. And again, the big thing here is when it's in a negative phase, similar to the negative phase of the North Atlantic Oscillation, it corresponds with widespread cooling across the central and eastern portions of North America. And as we've seen the PDO be positive over the last couple of winters, the EPO has largely remained negative over the last two winters. And again, that's led to the colder and snowier conditions that we've seen at various times over the last two winters, especially with the winter 2 years ago when we had all the snow and the really cold weather in January and February. So, taking all this into account, I know it's been a lot of information, but just want to leave you with some general thoughts as we go out into the winter. Again, I mentioned this before, just saying warm and dry this winter is not going to be a good forecast. Are there going to be periods that are warm and dry? Yes. We've already seen that here in December with the temperatures near 70 in the second week of December, which just unheard of. That's the warmest we've ever been so late in the year. But as time goes on and as the El Nino begins to weaken, it's going to become a fight between the El Nino and the teleconnection patterns, and particularly the positive Pacific Decadal Oscillation and the negative East Pacific Oscillation, which would promote more unsettled conditions, cooler conditions, potential for more snow. It should be noted that there hasn't been a well-documented El Nino event that has unfolded across the North Pacific Ocean, has unfolded with the North Pacific Ocean as warm as it's been during the development of this year's El Nino. And that's including that warm blob of water I was talking about that's sitting off of the west coast of North America. And I think the timing of the El Nino peak is going to be critical to our impacts going forward through the second half of the winter. We have been warm, and in fact, when we look at the strongest and even some of the moderately strong El Ninos, December tends to be warm. But that doesn't necessarily mean January and February are going to be that way as well. And if the El Nino weakens and starts to behave more like a moderate El Nino, the influence of that will be weaker, and it may enable other factors such as the PDO and the EPO and other teleconnection patterns to influence our weather as we go through the second half of the winter. So, warmer December followed by cooler temperatures during the second half of the winter is still our thinking. As we get into the fall, we'll see a return to warmer temperatures, but again, it's going to be a granted, because there's so much we're looking at, the forecasts are lower in confidence for temperatures and snowfall amounts. But our general feeling, and this may need to be updated a little bit. I have near to slightly colder than normal temperatures over central Indiana. It may end up being near to slightly warmer than normal. And the reason I say that is because, if our temperatures end up 10 to maybe as much as 12 degrees above normal for the month of December, even if we're colder than normal in January and February, the difference in temperatures may be so great here in December that it may keep us warmer than normal on average for the entire winter. Doesn't mean we're going to be colder later on. I think we will be. I think snowfall is going to be near normal, and what we have is 20 to 25 inches of snow. We do think the potential is going to be there for more chances for snow as we go later in the winter. Talking about that stronger jet storm track to the south of us, anytime that gets pulled up into the Ohio Valley and we have enough cold air in place, the potential is going to be there to maybe see a really good dousing of snowfall. At the same time, low-level temperature profiles will be critical, and if they're marginal, that could also trend more towards sloppier conditions, where maybe we're dealing with a mixture of precipitation types, not just snow, but freezing rain, the dreaded ice word. No one likes ice, but unfortunately that may be a factor. The other thing is we may have situations, periods of time where it's much warmer than normal. We have a strong storm system come into the Great Lakes, and it may be warm enough for thunderstorms and maybe even strong thunderstorms or severe thunderstorms. Not out of the realm of possibility. We do feel strongest about the drier than normal precipitation, but as I've mentioned several times, that doesn't necessarily mean less snow. The best example of that I can give you is in January 2014, 2 years ago, during our strongest, our very snowy winter that we had nearly 27 inches of snowfall in Indianapolis in January, which is actually more than we typically see in the entire year. We did that with below normal precipitation to the tune of about a half an inch. And that was due to the fact that it was so cold that the snow that was falling, it was a drier snow and just didn't have a lot of liquid content to it. So be careful when you see drier than normal. That does not always mean less snow. Finally, just a couple of links that we'll finish up with. Certainly any questions regarding climate, feel free to link to our office here, Climate Prediction Center's website, and they also have an El Nino website where you can get more information if you're interested. As well, you can always contact us here at the Weather Service in Indianapolis via Facebook, Twitter, or by phone. We're always happy to take questions regarding that. But with that, I want to thank you for viewing this, and certainly as we go out through the winter, we'll see how that all plays out. Thank you again.